This is a video on similarity and we are doing example 10. Circle ABC and ABD intersect at A and B respectively. AC is a tangent to circle ABD. AC is a tangent to this circle. AD is a tangent to circle ABC. AD is a tangent to this circle. Prove that A length BC divided by length AC is equal to length AB divided by length AD. Now, this example is a little bit different from the ones we have done in the previous videos, because usually they tell us to prove that two triangles are similar, right? And when after proving that the two triangles are similar, we already know the corresponding sides of the triangles and the corresponding angles. But in this question, they just skip the part where we have to prove that these two triangles are similar, and they ask us to prove that the corresponding sides are in the same proportion. So in order for us to answer this, we need to prove that the two triangles are similar, and we need to figure out ourselves which sides are proportional. This is how we do it. We need to figure out which angles of triangle BAD are correspondingly equal to those of triangle BCA. So when I look at my diagram, since AD is a tangent to this circle, I have an angle between my tangent and this chord, and this angle A2 is equal to angle C. So I have angle A2 is equal to angle C through the tan chord theorem. So I already have the first corresponding angles of my triangles. Then again, since AC is a tangent to this circle, I have an angle between my tangent, this tangent, and this chord. And this angle A1, is equal to the angle in the alternate segment, which is angle D. So I have angle D is equal to angle A1. Now remember, when we prove similarity, we only need two reasons, right? So even if we don't see which angles are we left with, angle B1 and angle B2, even though we can't prove that angle B1 is equal to angle B2, they are the only angles, they are the only two angles that we haven't proved. So we will just say these are the third angle of a triangle, angle B1 and angle B2. So now we have the corresponding angles of our triangles. We need to name our triangles accordingly so that the corresponding angles match. When we go back to our statement, we are required to prove that BC divided by AC is proportional to AB divided by AD. Now we can get our triangles from this statement, but we won't know in which order are we supposed to sequence the sides. The first way to look at it is focusing on one fraction. So we have BCAC. If I say BCA, is that a triangle? BCA, yes. So we have triangle BCA, and when I focus on this fraction, let me see ABD. Is it a triangle? ABD, yes. Triangle ABD. But the sides of these triangles are not in a corresponding order. You see, B doesn't correspond with A. You see, C doesn't correspond with B. So we need to name them. We need to rewrite this in the corresponding order. And this is going to help us put our triangles in the way that the angles correspond. So we have in triangle, we have B and triangle B, angle B corresponds with angle B. So we say in triangle B and B so that the B's correspond. Then we have A and C. Triangle BAA corresponds with C. So on this side we have triangle BA, and on this side we have triangle BC, so this one is going to be BCA, and A corresponds with D, so we have triangle BAD and triangle BCA. Now this is the way we should write this, so the angles are now corresponding, so we can then prove similarity. So things become easy now because we have already made note of which angles are equal to which angles of the other triangle. So we have angle A2 is equal to angle C. We saw that through the Tancred theorem. And our second reason, we have angle A1 being equal to angle D, angle A1 being equal to angle D. How did we know that? Well, angle D is an angle in the alternate segment, and it is equal to this angle between the tangent and the chord. So we use the Tancred theorem. Now the third reason, angle B1 is equal to angle B2. We can just say this is the third angle of triangle. Therefore, we have proved that triangle BAD is similar to triangle BCA, because we have proven that three corresponding angles of each triangle are equal to the other triangle. Now this is the correct sequence of letters to represent our triangles. So from this, we can now take out all the corresponding sides like we usually do. So we have BA divided by BC is proportional to side AD divided by side CA is also proportional to BD, side BD divided by side BA. And now let's take out the pair that we're going to use to answer number A. So number A, we have BC. Yes, we have BC, AC, this is CA. We have AB and AD, AB and AD. Oh, this is also AB. So we are going to use this pair. You can write your reason here. The reason why you say these ratios are equal is because they are the corresponding sides of triangles in the same proportion. As long as we have proved that your triangles are similar, then their sides, the ratios of their sides are proportional. So we're going to take out this pair. BA divided by BC is equal to AD divided by CA. Now, is it the same to what they asked us to prove? No, it is not. We were required to prove that DAB divided by AD. Now, they are not the same, right? On what they asked us to prove, AD is a denominator, and on this side we have AD as a numerator. So we need to rearrange this so that it gives us this. So let's cross multiply. We have BA times CA is equal to BC times AD. On this side we want to make BC our numerator. So we divide by AD, divide by AD. This AD will cancel with this AD. I'm going to write this on the left hand side. So we have BC divided by 1 is equal to BA multiplied by CA all divided by AD. Now on this side we want to get rid of CA so that it is a denominator on this side. So in order for us to get rid of CA, we multiply by 1 over CA on this side, and we multiply by 1 over CA on this side. So we will be having 1 multiplying by BC. We will have BC divided by CA multiplied by 1. We will have, I'm going to write it as AC so that it resembles what we were supposed to prove. So CA is AC is equal to this. CA is going to cancel with this one, and we will be having AB divided by AD. Now this is what they asked us to prove. So we have proven that this pair of corresponding sides are proportional. Now B, we are required to prove that BD. Now that we know that our two triangles are similar to one another, we can just always go back to our corresponding sides that are proportional and take out what they want us to prove. But then we need to put this in a form that we are used to. We need to make it a fraction like this one. So the way to do that is to expand. So we have AB squared is, you get it when you multiply two ABs together, is equal to BC times BD. Now this is what you get after you cross multiply, right? So we need to just reverse it. So this is my first number, it is my numerator. This is my second number. This is how I do it. So my third number will be my new numerator on one side, and this is the fourth number. So I will be having 1 AB divided by 2 BC is equal to 3 BD divided by 4 AB. Now we have reversed engineered what they gave us into the fraction that we are used to. If you go back, you will be having AB times AB, that's AB squared, BC times BD, that's BC times BD. So this is what we are looking for from here. So we have AB, and we also have AB, BC, BD, and so we are only going to take this pair. So we have BA divided by BC is proportional to BD divided by BA. Now what's the reason here? These are corresponding sides of triangles in proportion. So now we just need to rearrange this so that it resembles what they asked us to prove. So we are going to have AB divided by BC is proportional to BD divided by AB. And now AB is going to multiply with AB, and we will get AB squared is proportional to BC multiplied by BD. Now this is the same as what they asked us to prove. So we have proven that this side multiplied by itself is equal, or it is proportional to this pair of sides multiplied when they are multiplied together. So this is how to solve similarity questions when they don't ask you or show you which triangles are similar and which sides of the two triangles are corresponding. Thank you for watching.